So today we are doing 6.2a, starting with 6.2a. What you need to remember is that there are properties for roots, okay? So if you have any root with a number that are both being multiplied together, you could separate them into two roots, okay? Being multiplied. This means the same thing as this, right? And vice versa. When you have the square root of a fraction, you can separate it into two roots. These are not new things. They're just reminders, okay? So, example 1, how many will I need on this one in order to pull out a group? 4. So 625, and if you guys forget, there is a list of common squares on the wall. You could take a picture of it if you wanted to, or write them down. But 625 is 25 squared. So we have 25 times 25, and then each of the 25s break down to 5 and 5. So we have 4 5s, okay, with no numbers left over. So now when you go to the 8s, instead of writing out, or not 8s, x's, instead of writing out 8 x's, how many do you need for a group? 4. So we're going to end up with 2 groups, but what I like to do is write it as x to the 4th times x to the 4th, because I have one group of x's and another group of x's. So that just reminds me that I have 4 x's, that makes one group, another 4 x's makes another group. Really?
Yeah, a little bit.
So do you agree that x to the 8th is really 1, 2, 3, 4, 5, 6, 7, 8. So you could write it out like that, and then you circle 4, that makes a group. You circle another 4, and that makes a group.
Oh, okay.
So I'm just basically doing a shortcut since I know that 4 x's, I need 4 x's to make a group. I'm just writing that as x to the 4th and x to the 4th. Okay, so then I have y to the 4th, so that's making one group, right? And then z to the 12th, if I take 12 divided by 4, that's going to make 3 of them. So I'm going to write z to the 4th 3 times, because that makes 12, right? So is there anything left over under this root? Is there anything that didn't make a group? Yes?
Could you have done something with the 5s and did it, because it'll break down into 4 5s, so could it have just done like, never mind, I don't know the question.
Okay. So what am I going to write my answer as? How many groups of 5s do I have? 1, so that's 5. How many groups of x's do I have? 2. So that's x to the 2nd. How many groups of y's? 1. So that's just y. How many groups of z's? So that's z to the 3rd. Did I have anything that didn't make it into a group? So there's nothing left over in the root. That is my answer. Okay, you guys try example 2 on your own.
Wait. Why didn't we do like y squared times y squared?
Because you need 4 for a group. So I have exactly 4 y's, which makes one group.
This is 4 5.
Yeah, try example 2 on your own. Did you try it? At what part? So can you group the A's? Is there 3 of them? So that's what I would like box to remind yourself it needs to stay inside, and then move on to the B's. Okay. All right, so I'm going to be pulling popsicle sticks for you guys to help me with each step. Okay, so 27, what does 27 break down to? 3, 3, and 3. 9 times 3, and 9 breaks down to 3 and 3. So I have a group of 3s. Okay, so a squared, that's only two a's, and how many do we need for a group? Three. So I'm going to box this one because it's going to stay inside. I circle the groups, I box whatever has to stay inside. B to the 7th. So if you split this up, I need 3 for a group, right? So I'm going to have b to the 3rd and b to the 3rd. That makes how many? 6. And then I have 1 left over, which makes my 7 b's, correct? So I have 2 groups of b's with 1 b left over inside. How am I going to split up my c's? C to the 3rd, because I need 3 for a group, right? And then how many c's are left over? 1. So I have 1 group of c's with 1 c left over. So when I write this one out, remember all of our groups go to the front. Okay, so I want somebody to tell me what I'm writing in front. Shannon, what do I write in front? 3. Because how many, so I have a group of 3's. There's no groups for the A's. That's going to stay inside. How many groups of B's? 2 of them. There's 2 groups. 1, 2 groups, right? So since there's 2 groups, it's going to be B squared. How many groups of C's are there?
2.
1 group. This is the boxes are leftovers. There's 1 group of C's, so then we have the C. Then we write, don't forget you need to write that cubed root right there, okay? So somebody tell me what goes inside. Vienna, what goes inside the root? A squared, B, and C. Okay, that is my answer. Ask me some questions. Raise your hand to ask me a question. How many do you need for a group?
3.
So you can only group 3 together. And that makes 1 group that got brought out and was a C. And there was 1 C left over, so that set to stay inside. Okay? And you do not forget to write that cube there, because that's representing that you need 3 for a group. If you forget that 3, you get it wrong. Okay? So whatever the root is, make sure you have that there. Other questions? Chris, Eric, do you guys have any questions for me?
No, we do not.
Okay, let's focus here while we're doing notes. Okay, example 3. Let's go ahead and break down what I can first with our roots. So 27 breaks down to what? 3, 3, and 3. Okay, I'm going to write this as the 4th root of 3 times 3 times 3. And then I still have 15 on the top, right? Well, we can't have roots in the denominator, correct? So, how many more 3's do I need? I need 1 more. So what you're going to do is we are going to write this as, we're going to multiply the top and the bottom by the 4th root of 3. Because then that is going to give me my 4 3's that I need to get rid of the root in the denominator. Because remember, if we go back here to our properties, multiplying them is the same thing as having all of them under the same root. So by multiplying here by 1 more 4th root of 3, I have made 4 3's so that I have a group that I can pull out. So I have a 3 in the denominator, and then what do I have in my numerator? 15 4th root of 3, because there's nothing I can pull out there. So this doesn't have a root. We're just multiplying these together. So we just end up putting them together like that, right? And then can this be reduced at all? Yes, because our outside numbers can be reduced. So 3 goes into 15 how many times?
5.
So my answer is 5 4th root of 3. Questions? Okay, example 4. First thing I would do is split this into 2 roots. So we have a 5th root of 3 on the top, and a fifth root of 4 in the denominator. How many do I need for a group? 5 of them, right? How could I rewrite 4? With multiplication. Okay, we're going to write, 4 breaks down to 2 times 2. So this is really the fifth root of 2 times 2 in the denominator. And then I have the fifth root of 3 on the top. So how many more 2's do I need in order to make a group? We need 3 more 2's, right? So we're going to multiply by the fifth root of 2 times 2 times 2, so that I have 5 2's. So we're multiplying the top times the fifth root of 2 times 2 times 2. So this makes how many groups? 1, because we need 5 2's in order to make a group.
How'd you get 3 2's?
How did I get it?
Yeah, you got 3 2's.
Right. 4 breaks down to 2 times 2, but I can't have a root in the denominator.
Yeah.
So in order to get rid of this in the denominator, I need 3 more, because fifth root means we need 5 2's. So I know I already have 2, so in order to make 5, I need 3 more.
Yeah, but you just pull them out of nowhere.
That's we're multiplying to the top and the bottom. So whatever you need for the denominator, you choose that, but you have to make sure you do the same things to the top. So what is in my denominator now? 2. Now, can I pull anything out on the top? No. So you multiply all these numbers together, and you end up getting the fifth root of 24 is correct. Because 2 times 2 times 2 is 8, and 8 times 3 is 24. Can I reduce this one at all?
No.
No, because in order to reduce, you have to have a number in front, right? Both of them have to be in front, or both of them in a root. So this is your answer right here. Okay, I would like you to try 5 on your own. Read your answer if you want to either put it on your whiteboard, or I can come by and look at it. Except for the 4 should be like in the root part, because it looks like it's saying. No, it's supposed to be the fourth root.
Oh, I know.
Yes, good. Okay.
So I didn't blow my nose.
Yes, you may. Okay, what does 8 break down to? 2 times 2 times 2. So 8 breaks down to the fourth root of 2 times 2 times 2. Okay, on the top I still have a 2. But how many 2's do I need in order to make a group? 4. We need 4. So how many more do I need? 1. So we're multiplying by the fourth root of 2 to the top and the bottom. Okay? Because I already have 3 and I just need 1 more. Because I need 1 more to make 4. This now has 4 2's. So my denominator is 2. And then my numerator is 2 fourth root of 2. And then we can reduce. Both of those 2's in front cancel out. And so my answer I'm left with is just the fourth root of 2. Make sure that your 4 is small inside that little root thing. Okay? Otherwise, if it's out in front, it looks like it's 4 root 2. Okay, question?
Oh, we have 30 seconds left.
Oh my goodness, thank you. Okay, I'm going to go ahead and stop this.